Okay. To find the vertex, the x-coordinate of the vertex is minus b over 2a. I write that every time, by the way, even now, which is minus 4 over 2 times minus 1, which is minus 4 over minus 2, which is a plus 2. And the y-coordinate of the vertex is f of 2, which is minus 2 squared plus 4 times 2, which is minus 4 plus 8, or 4. By the way, now I can answer a lot of questions because I can do a quick and dirty graph. How does this guy open? Down. And he has a vertex at 2, 4. So without even graphing, of course I know the domain is all real numbers. And without the graph, the range would start at minus infinity and go to 4. All I need is the vertex for that. Axis of symmetry is the x-coordinate of the vertex because it breaks it in half. We know it opens down. Does it have a maximum or a minimum? Well, from my crude graph, I know it's got a top, which is a max. The max or minimum value is the y-coordinate of the vertex. Now, x-intercepts, y-intercepts are something which takes some work to do. I can't get them from my crude graph. I could get increasing and decreasing from my crude graph. It says where is f of x increasing, where is f of x decreasing, and this says for what x is y increasing. Increasing means going up. And then for what x is y decreasing. That means going down. If I just take a look at the crude graph I drew, and I can get it off the graph that I'm going to draw in the end, but the crude graph I drew that says here's x. X is moving from left to right. The y values are increasing till it gets to x equal 2. So y is going up until you hit x equal 2. Then as x moves beyond 2, y is going down. So the way this sucker works, that says y is going up or increasing for x minus infinity to 2, and you don't have a square bracket there because at 2 it's neither increasing nor decreasing, and then going down from 2 to infinity. The answer is always in x. Pardon me?
It wouldn't be negative infinity?
It's negative infinity to 2.
Yeah, but the decreasing?
No, because decreasing, it's the x values.
Oh, okay.
So x is going from minus infinity to plus infinity.
Okay.
Y may be going to negative infinity,
Okay.
but it's x who's in charge.
Okay.
So now I can kind of finish the problem. What are the x-intercepts? That means y equals 0, or minus x squared plus 4x equals 0. I've got a greatest common factor of minus x. I don't like a leading coefficient of negative 1. So anytime I got a leading coefficient of negative, I pull out the minus 1. That makes it easier to factor. So this gives me an x of 0 and an x of 4. Now I ask you on the test to write them as coordinate points. In this particular instance, if you said x equals 0, x equals 4, that would still be correct, because did I say write them as coordinate points? No. But on a test, it literally says write them as a coordinate point. And the y-intercept is where x equals 0. So I'll have negative 0 squared plus 4 times 0. And that's 0. So this is also 0, 0. So I now have enough information to do a graph. By the way, if you ran out of time and you wanted to get the graph points, do I know what this graph looks like? Yes. I have the vertex. Put the vertex in, draw him downward. Just plop him on the paper. You'll get the majority of the credit for the graph. I don't have time to do the other stuff, so I'll go back and do that. So I know that my vertex is at 2, 4. 1, 2, 3, 4. I have an x-intercept at 0, 0, and 4, 0. And then just draw him down. And there he is.